Okay, so here's a conditional probability problem where we will actually have to use this formula with the probabilities. It's a little bit different than when you have a table. So in this case, we have a school that has 60% of students buy a school lunch, and only 10% of the students buy lunch and dessert. And we want to know what's the probability that a student who buys lunch also buys dessert. Now, I will tell you that if you try to solve problems like this using your intuition, you will have issues. It turns out this problem is an excellent example for why we actually study math in school, because you need the academic knowledge. So let's take a look and let's try to think this out. Why is this problem not that intuitive? Because you'd think, what's the probability that a student who buys lunch also buys dessert? You'd think the answer would just be 10%, right? Only 10% of students buy lunch and dessert. But that's not the answer. See, the thing here is this, is our situation is this. We're looking at what is the probability that somebody buys dessert, given the fact that they buy lunch. Okay, so we're going to take a look and see if we can use this formula. So let's see here. So B and then A. So probability of A and B. What's the probability of A and B? We're told that it's 10%. The probability that they get a lunch and they get dessert, 10% of the students. So that's 0.1. And then probability that they, let's see, our A is lunch. Probability that they get a lunch is 60%. So that's 0.6. And if we do the math, this actually turns out to be like 1/6, which again is approximately 0.17 or 17%. Again, we write probabilities in either one of these three ways, fractions, decimals, and percents. But it's always going to be a number between 0 and 1 for probability. What else? Okay, the other thing I wanted to talk about is, now that I've explained how to do the math, I want to give you a little bit of background so maybe you can make sense of this. When I first looked at it, I was not really sure why the math works the way that it does. Why is it that we have to take into account the 60%? So let's run some numbers. Let's pretend like there's 100 students, or I'll call them kids because it'll take me less to write it. Okay, let's assume there's 100 kids at the school. And if 60% of them buy lunch, then we would say 60 get lunch. I'm just going to write 60L. And then we also know that 10% get lunch and dessert. So we'll say 10 because 10% is 10 of 100, they get lunch and they get dessert. That's my little and symbol. Sorry about that. So anyways, so then the question is, what about, how could we then answer this question? What is the probability that a student who buys lunch also buys dessert? Well, again, you have this weirdness that you have to read the question in this way. What is the probability that a student who buys lunch, in other words, buying the lunch is given, okay, and then also buys dessert? And so in this case, we know 60 students buy lunch. And if we want to know the probability that they get lunch and dessert, we have to do 10 out of 60, not 10 out of 100, because it's what's the probability that they're getting lunch and dessert, not out of the 100 kids, but we're assuming they're getting lunch and they also, by the way, buy dessert. So in this case, we would do 10 over 60, and we get the same exact result as 1/6. All right, I don't know if this helped you a lot, but I thought I would throw it in there just in case.